Hi, I'm Madeline. I'm here with Fornew at Site 1 in Middlesbrough, about to look around the AD plant. I've got my hard hat on, so let's go.
Hello, right, so welcome to our site. This is Bioconstruct Imperial Park. Okay, so I'll take you into the first section of the business. So this is our reception facility. This is where the tankers come into the facility and we unload their material that they've got into our reception building, into our pre-storage tanks. This is the reception building. This is where the tankers come in. They'll park up in here and then we'll unload the material using our pumping equipment on site, which then will be stored in our pre-storage tanks. This is our pre-storage facility. Within this facility we have 1,000 metres cubed of storage capacity. We have 7 different tanks, so we can blend and we can look to change different recipes and feed the material to the plant once we've determined the calorific value of the material, which is done in our on-site laboratory, which is the other side of the site, from samples that we take from all the deliveries that we take to site. Okay. This is our reception building number 2. This is where we can take solid and semi-solid materials into the mixing pit down the bottom. Lifts up. Do you want to jump show this here? So this is our mixing pit. So what we can do, we have the tipper trucks will reverse into the facility, the lid will be lifted up and we'll be able to tip that material into this pit where we can dilute that material down to make it pumpable, and then we can transfer that material then from the reception pit into our reception pre-storage tanks, which then can be fed as per the feeding schedule into the plant itself. Okay. Area where we can take solid materials, which you can see, we can take fruits, and the material you can see there now is actually a chicken litter. Okay, that material is tipped on the floor outside here. We can then take that material using the Merlot and we feed it into the Big Silver Big Mix, which is where the material is mixed with substrate from the fermenter and made pumpable, so we can pump it back into the system for to start it into the anaerobic digestion process. Standing up here is a good view where you can see the layout of the plant itself. So once the material has been tipped into the reception building, we decide the calorific value of that material is and what feed rate we want to feed that into the fermenters at. It is then transferred via substrate pumping equipment from the reception building into the 2 primary fermenters. Each one of our primary fermenters has got a capacity of 5,700 metres cubed. Then we have a post fermenter, which has got a volume of 7,500 metres cubed. And within that area of the site, we have a 65-day retention cycle. The retention cycle is basically, it gives the material that we're feeding into it enough time to digest so we can get extract as much biogas from that product as possible. Okay? Once it's been through the 65-day retention cycle, we then need to pasteurise the product. We have 5 20-metre cubed pasteurisation tanks, the silver tank that you can see there. Once it comes out of the fermenters and the post fermenter, it then goes through that pasteurisation process. What we do, we take it from the temperature that we run anaerobic digestion at 40 degrees. We then heat the substrate up to 70 degrees for 1 hour. Once it's been through that, then we get full bacterial kill, and that material then is transferred into one of these 8,000 cube storage tanks that we have on site. Okay, so that's how the liquid is handled. So the biogas, which is the product that we are producing, is made in these 3 tanks. Okay, the gas is then stored in the gas dome roofs. Okay, so the gas is then flowed all the way around, it can go all the way through the system, and then it goes through this, which is our desulfurization plant. Food waste biogas normally has a lot of H2S. H2S needs to be removed so we can run the gas through gas engines. This desulfurization plant is able to reduce the H2S volumes by around about 5,000 ppm. So we can have a 5,000 ppm input and it will come out at 10 or 20. Okay, so once it's been through this, it then goes into the next area of our plant, which is our gas upgrading plant and gas compression. Okay, so the gas will come into this at an ambient pressure of around 3 millibar. Okay, we need to then compress that gas up to 120 millibar to be able to run it through the gas engines. Okay, so this, inside this container we have 3 gas compressors, and we take that up to that pressure of 120 millibar to be able to run the engines. The 2 silver cans there that you see inside there, they're full of activated carbon. That does the final polish of the biogas, so that removes any residual H2S elements in that gas, and then once that gas goes through there, we will have 0 H2S in our biogas, so it will be a clean combustible gas for the engines. Okay? Over here is our emergency flare. So basically we are able to then see if we are working at full production, we will still be able to burn off any excess gas so we don't have to vent it to the atmosphere should there be any problem with our gas engines and we can't use the gas that we are actually producing. And that's what the flare stack is for. This building here houses our CHP engines, so this is the final product. This is where the gas is used to run gas engines, which then produce the electrical power that we export to grid. These 2 rooms on our CHP are our HV and our LV distribution rooms. The LV room uses the parasitic load from the engines to power the plant. So the electricity that we are producing, we use to run our own plant. The room next door is where the HV outlet is. So we have the switchboards in there that then take the HV via a cable underneath all the building to a substation that's just on the back of the plant. So this area is where we house our 4 CHP gas engines. We have 3 Jenbacher 420 gas engines that produce 1.5 megawatt of electrical power each, and we have 1 312 Jenbacher engine which produces 500 kilowatts. I'll show you in this room now that the engine's actually not running. This is the small Jenbacher that we run. This is a 500 kilowatt gas engine. Panel, an instrumentation panel which shows the 1.5 megawatt or 1,500 kilowatt nearly. That's what that engine is currently producing at the moment. Okay, so we're currently now producing 4.5 megawatts of electrical power as we do this to it. And this is our standby generator that in the case of a power cut, we still need to be able to run the critical pieces of equipment kit that we've got on site. This standby generator then will power in the event of a power failure and we can't run the engines. This will then take over the critical parts of the plant to stop it being any problems health and safety wise or from the environmental agency. Okay?
Well, that's it from us at Site 1, so I'm going to head on over to Site 2 and do the same. See you later.